Good morning students, today is day 18. Today we will discuss some important questions related to chapter derivative. So the first question, log root 1 plus x square minus x equals to y root 1 plus x square. Show that 1 plus x square dy bata dx plus xy plus 1 equals to 0. So this is the question, first question for today. Now solution, log root 1 plus x square minus x equals to y root 1 plus x square. Now differentiate with respect to x on both sides. Now what is the derivative of log theta? This is theta. The derivative of log theta is 1 upon theta. After then the derivative of theta. Now derivative of root 1 plus x square is 1 upon 2 root 1 plus x square into 2x minus the derivative of x is 1. Again right hand side we use product rule because there are two terms. So first term the derivative of second term plus second term the derivative of first term. Now 2 cancel, 2 cancel, we left with 1 upon root 1 plus x square minus x. Now we take LCM. Now by taking LCM we can get with this equation. Now again y x upon root 1 plus x square plus root 1 plus x square dy bata dx. So take minus from this term. So this becomes root 1 plus x square minus x upon root 1 plus x square minus x root 1 plus x square. Now take LCM in the right hand side. LCM is root 1 plus x square. So yx plus root 1 plus this becomes 1 plus x square dy upon dx. So this one cancel out. This one again cancel out. So we left with minus 1 equals to yx plus 1 plus x square dy upon dx. Now shift this minus 1 to right hand side. So we left with hence proved we solve the given equation equals to 0. So this is the first question, very important question. Now we shift to the second question. The second question, please note down these questions on your fair notebook. Please, all the questions you have to write down on your fair notebooks. So the next question, second, if y equals to tan inverse 5x upon 1 minus x square, then prove that dy upon dx equals to 2 upon 1 plus 4x square plus 3 upon 1 plus 9x square. Now this is a question. How can we solve this question? So y equals to, solution equals to tan inverse. Now we can write 5x as 3x plus 2x upon 1 minus, and we can write 6x square as 3x into 2x. Now this is the formula, please note down the formula. The formula of tan inverse A plus B upon 1 minus AB. Tan inverse A plus B upon 1 minus AB, the formula of this is tan inverse A plus tan inverse B. So now tan inverse A plus B, 1 minus AB, it becomes tan inverse A plus tan inverse B. Now differentiate with respect to x on both sides. The derivative of y, dy by dx, tan inverse theta. Now what is the derivative of tan inverse theta? Tan inverse theta 1 upon 1 plus theta square. So 1 upon 1 plus theta square. After that, derivative of theta. Theta is 3x. So derivative is 3. So 1 upon 1 plus 2x square. After the derivative of 2x is 2. So dy by dx equals to 3 upon 1 plus 9x square, 2 upon 1 plus 4x square. So hence we proved the value of dy by dx equals to 2 upon 1 plus 4x square plus 3 upon 1 plus 9x square. Now shift to the third question. The third question is, y equals to tan inverse x upon 1 plus 6x square. The question is saying, prove that dy upon dx equals to 3 upon 1 plus 9x square minus 2 upon 1 plus 4x square. So in this question, y equals to tan inverse. Now we can write x as a 3x minus 2x upon 1 plus 3x into 2x. So y equals to tan inverse 3x minus tan inverse 2x. Now differentiate with respect to x. So dy by dx equals to 1 upon 1 plus 9x square into 3 minus 1 upon 1 plus 4x square into 2. So the final answer is 3 upon 1 plus 9x square minus 2 upon 1 plus 4x square. So this is the third question. Please note it down. The next question is, if x equals to ex upon y, prove that dy by dx equals to x minus y upon x log x. So this is a question. Now, how can we prove that the value of dy by dx equals to x minus y upon x log x? So solution, x equals to ex upon y. Now taking log on both sides, log x equals to log ex upon y. So log x equals to x upon y log e. Now the value of log e is 1. So we left with log x equals to x upon y. Now differentiate with respect to x. 1 upon x equals to quotient rule. Now what is quotient rule? The square of denominator derivative of numerator minus numerator derivative of denominator. So 1 upon x equals to y square, y 1 minus x dy bata dx. So shift this y square to this side. Y square upon x equals to y minus x dy bata dx. So x dy bata dx equals to y minus y square upon x. So x dy bata dx. Now we take common. Sorry. This becomes y minus y square upon x. Now we take LCM. xy minus y square. Now x dy bata dx equal to take common. So x minus y upon x. So. Now we know the value of x upon y is log x. The value of x upon y is log x. So the value of y upon x becomes 1 upon log x. So the value of dy bata dx is x minus y upon x log x. So the important point to be remembered in this question is the value of y upon x. We have to put the value of y upon x from this equation. The value of x upon y is log x. Just put the value of y upon, that is 1 upon log x. Shift this x to right hand side. We can easily find the value of dy bata dx, x minus y upon x log x. Now we shift to the next question, the question number 5. Question number 5. So the 5th question is y equals to sine inverse x. Prove that d square y upon dx square equals to x upon 1 minus x square 3 by 2. So we have to prove d square double derivative equals to x upon 1 minus x square 3 by 2. So now solution. The question is y equals to sine inverse x. Now differentiate with respect to x. This is dy upon dx. This is 1 upon root 1 minus x square. Now shift again the same logic. Whenever there is a denominator in the first derivative, shift that derivative to left side. So 1 minus x square dy bata dx equals to 1. Now to eliminate this root, squaring on both sides. Again differentiate with respect to x. Now there are two terms. We use product rule. First term same, the derivative of second term plus second term same, the derivative of first, which is equals to, derivative of first. The derivative of first is minus 2x equals to 0. Now we take common. What are the common terms from 1 and 2? 2 dy beta dx. So 2 dy beta dx, we left with 1 minus x square d square y upon dx square minus x dy beta dx equals to 0. So 1 minus x square d square y upon dx square minus x dy beta dx equals to 0. 1 minus x square d square y upon dx square equals to x dy beta dx. We shift this term to right side because we have to find the value of double derivative. So 1 minus x square d square y upon dx square x. Now what is the value of dy beta dx? From equation first, suppose this is equation first, the value of dy beta dx is 1 upon root 1 minus x square. Put this value 1 upon root 1 minus x square. So finally the value of d square y upon dx square is x upon root 1 minus x square into 1 minus x square. Now d square y upon d x square equals to x upon. Now we can write this term as a 1 minus x square half 1 minus x square raised to power 1. Now in the denominator the base is same. So we add on the pass. So this becomes half plus 1 raised to power 3 by 2. So the important point in this question is we have to put the value of dy beta dx in this equation. So remember this point. Now shift to the next question. The next question is question number 6. The question number 6 is y equals to sin p sin inverse x. Then prove that 1 minus x square d square y upon dx square minus x dy beta dx plus p square y equals to 0. Now y equals to sin p, the y equals to sin p inverse x. We have to prove the given equation equals to 0. So the question is y equals to sin p sin inverse x, derivative on both sides. Now this is sin theta. Now derivative of sin theta is cos theta. After that the derivative of theta is this, p is constant. Derivative of sin inverse x is 1 upon root 1 minus x square. Now again, in first order derivative, whenever there is a denominator, shift that denominator to left side. So 1 minus x square dy beta dx equals to p cos p sin inverse x. So now again differentiate with respect to x. Now there are two terms. First term same, the derivative of second, plus second term same, the derivative of first equals to, again p is constant, cos theta. Now this is cos theta. The formula is minus sin theta. Further, the derivative of theta is p upon root 1 upon 1 minus x square. So the whole equation becomes 2 cancels. Now we take LCM. LCM is 1 minus x square. This becomes 1 minus x square d square y upon dx square. This one can cancel out. So we left with plus minus x dy bata dx equals to minus p into p square. Now sin p sin inverse, the value is y upon root 1 minus x square. Cancel. So the final answer is 1 minus x square d square y upon dx square minus x dy bata dx. Shift this term to left side. So the final answer is proved. So this is a sixth question. Now the next one, very important question. The last one. So the last one is seventh question. The question is, if x equals to tan 1 upon a log y, tan 1 upon a log y, prove that 1 plus x square d square y upon dx square plus 2x minus a dy bata dx equals to 0. So very important question. So solution, the question is x equals to tan 1 upon a log y. Now if we derivative this equation on both sides, this will be more complicated. So first of all, shift this tan to this side. This becomes tan inverse x 1 upon a log y. First step is shift this tan to this side. This becomes tan inverse x. Now shift this a to left side, log y. Now differentiate with respect to x. A is constant. The derivative of tan inverse x is 1 upon 1 plus x square. The derivative of log y is 1 upon y dy bata dx. So the value of dy bata dx is a y upon 1 plus x square. So this is the first order derivative. Now shift this denominator to left side. So this becomes 1 plus x square dy bata dx equals to a y. Now product rule, first term the derivative of second term plus second term the derivative of first term a dy bata dx. So 1 plus x square d square y upon d x square 2x dy bata dx minus a dy bata dx equals to 0. Shift this term to left side. So now the final answer So the final answer is, now we take common dy by dx, we take dy by dx as a common from these two terms. So this is the final result of this question. Hence we proved the value of given equation equals to 0.